Okay, here is the review for test 4.2 on graphing trig functions and identifying the 6 trig functions. So let's begin with problem number 1. This is a cosine function, y equals 3 cosine 1/2 x minus 1. So we're going to begin by filling in the table and then graphing the function, and then we'll fill in the blanks at the top for amplitude, period, phase shift, and vertical shift. Alright, so I've completed the table. First of all, I looked here at my equation to see what transformations had occurred, and I look at the angle transformations first, and I noticed that right here I have a 1/2 times x. Well, this is the same thing as multiplying times 1/2 or dividing by 2. So I know that this is an insider, and I know that I'm going to have to do the opposite operation from what's inside the parentheses. So since this is changing my angle, that's going to happen in this column. So I multiply every angle by 2 since I'm doing the opposite operation. The opposite operation of multiplying by 1/2 is multiplying by 2. So 0 times 2 is 0. Pi over 2 times 2 is pi. Pi times 2 is 2 pi. 3 pi over 2 times 2 is 3 pi. And 2 pi times 2 is 4 pi. So these are going to be the angle measurements for my graph. Then I look to see what's happening on the outside, because these outsiders are going to change the vertical values or the y values of my graph. So I'm going to use the values for cosine for my y values. So cosine at 0 is 1. Cosine at pi over 2 is 0. Cosine at pi is -1. Then 0, then 1 as we go around the unit circle. Then I'm going to take those values and I'm going to apply these transformations. I have a multiply times 3 and a subtract 1. So to each one of these, I'm going to multiply times 3 and subtract 1. And when I do, I get the values 2, -1, -4, -1, and 2. Now what I'm going to do is I'm going to graph these values right here. This one and this one. These are the ones that I'm going to put on my graph. And when I get done graphing this, then I'll show you the completed graph. Okay, so I have graphed my points. The first thing I did was I graphed these angle measurements along my horizontal axis. This just helps me when I get ready to graph my wave to know what the x values are going to be before I start graphing. It just makes it a little bit easier. So I take all of these angle measurements and I put them along the x-axis. So 0, 0, I put a point here. Pi, I put a point at 2 pi, 3 pi, and 4 pi. This just helps me when I get ready to graph so I know exactly where to put the y values. Here are the y values. So at 0, I graphed a 2, then -1, then my -4, then my -1 again, and then back up to 2. And you see this makes a wave. Now remember, this is a wave. It's rounded. This is not pointed at all. It's rounded. And I even did one more wave backwards so that you could see that it goes down and it just repeats. So this basic shape is going to repeat over and over and over and over, and I could keep going if I wanted to. Okay, so that's it for the graph. Now we're going to answer the questions about amplitude, period, phase shift, and vertical shift. Okay, so our amplitude comes from this value right here. The amplitude measures how high the graph goes from the center. So if I draw a line right here through my center, which would be right here at y equals -1, And if I count how many spaces I have between there and my furthest point, my minimum and my maximum, that should be 3. So 1, 2, 3. So my amplitude is 3. My period is 4 pi. The period tells me how far I can go before the pattern starts to repeat again. So here I can go from here to here before I start repeating, and that is equal to 4 pi. This also shows up in the table right here. So we get 4 pi by multiplying our angle by 2, which is what we did right here. So the normal period for cosine and sine is 2 pi. So if I have a transformation here and I multiply my angle by 2, then that changes the period to 4 pi. There's no phase shift. There's nothing happening here after the x. I'm not adding or subtracting anything after the x inside the parentheses. So there's no phase shift. And there is a vertical shift down, which is this -1 right here. This -1 makes the graph shift down 1 unit. And that's where you can see the centered line right here is at y equals -1. And that's it. We've answered question 1. Now for question 2 and 3, I'm going to work a little bit quicker so that this video won't be quite so long. Alright, so far I have completed this table, and once again, I'm looking here to see what transformations I have. Right here, I have a change to the angle. This is called a phase shift. Anytime I'm adding or subtracting some angle from my angle that I already have, then I have a phase shift. So what I'm going to do here, since this says plus pi over 2, I'm actually going to subtract pi over 2 from my angle. So that's what I did here. I subtracted pi over 2 from each one of my angles, and I got these values here for my new angles. Then I took these values and I put them on my horizontal axis, and as you can see, this actually kind of shows you how this graph is being shifted to the left pi over 2. Then I took the values for sine, because that's what I'm graphing here. I'm graphing a sine wave. And I put those values in the y column. And sine at 0 is 0. Sine at pi over 2 is 1. Then 0, then -1, then 0 as I go around the circle. Then I do my transformations to y. That's going to be the outsiders. So I have to multiply by 2 and subtract 1. That's what's happening to this outside. So 0 times 2 is 0, is -1, and so forth. And I did these calculations, multiplied each one by 2 and subtracted 1, and I got -1, 1, -1, -3, -1. Now I'm ready to graph. Okay, so here's my wave. I graphed at -pi over 2 and -1, then 1, then -1 again, then -3, then -1 again. And what I end up with is this wave. And remember, these are rounded edges, not pointy. This is not pointy, it's a curve. So we want it to be nice and rounded. Now if I wanted to, I could keep repeating this wave up and down, all the way through my graph. But I only need you to do one wave for me, one period. That would be great. Okay? And that's it. That's all there is to that. Now let's answer the questions at the top. Amplitude. The amplitude for this graph is 2. So you always want to look right here for amplitude for sine and cosine. The period, again, is going to be the same as the regular period for sine and cosine, which is 2 pi, because it takes one complete revolution around the circle to start to repeat those waves. So 2 pi is my period. And I didn't have any stretches or compressions inside my parentheses, so since I didn't have any stretch or compression here, then my period is still going to be 2 pi. This time I had a phase shift though. And the phase shift here was this, the pi over 2. So this says plus pi over 2, but really what happens is we end up going to the left, pi over 2. So our phase shift then is going to be left pi over 2, or negative pi over 2. So we're going to write that in. And then the vertical shift. Well, again, we have a vertical shift of -1. So we're going to, you can write -1 or you can write down 1. That would be our vertical shift. All right, next we have tangent, a tangent graph. Now this graph is different. It's different from sine and cosine. There's a few things that happen differently with tangent that sine and cosine don't have. So as I go through this example, we'll discuss what these changes are. All right, once again, I always want to look up here at my equation to see what transformations I have going on. And so I can see that inside here, I do have a transformation to the tangent function for the angle measurements. And so this says x over 4. This means that I'm taking my angle measurements and dividing by 4 inside the parentheses. But I know that what I really need to do is outside the parentheses, I need to multiply by 4. So to all of my x values here, which are my horizontal values, my angle measurements, I'm going to multiply all of those by 4. All right, so when I multiply all of my tangent angle measurements by 4, I get -2 pi, negative pi, 0, pi, and 2 pi. Then I'm going to mark my horizontal axis with those points. The next thing I'm going to do is write in my values for tangent for this column that's under y. And so I know that tangent is undefined at negative pi over 2 and at pi over 2. And my values for tangent at negative pi over 4 are -1, tangent of 0 is 0, and tangent of pi over 4 is 1. Now I'm going to do the outside transformations. That would be these outside transformations right here. I'm multiplying by 2 and adding 1. So on these, I'm going to multiply by 2 and add 1. So times 2 plus 1. All right, so I put in my values for my transformations. And when I multiplied by 2 and added 1, I got these values. Well, undefined is just undefined. I can't change that. And then -1 times 2 is -2 plus 1 is -1. 0 times 2 is 0 plus 1 is 1. And 1 times 2 is 3. 1 times 2 is 2 plus 1 is 3. All right, so then I'm going to go ahead and graph my asymptotes. So you can see right here, I've graphed in the asymptotes. If you don't have asymptotes on your tangent graph, I'm going to count points off for that. So just so you know, if your graph has asymptotes in it, you must graph the asymptotes first before you graph the curve. The next thing I'm going to do is I'm going to put in the curve. So as you can see, my curve is pretty stretched out. And obviously, since we're multiplying our angles times 4, we stretched that curve out quite a lot. And so it's not very easy to see this top part of our graph right here, but it does curve out and goes up along the asymptote up here. It just, you can't see it because it's off the graph. But the main thing I'm going to be looking for is I'm going to be looking for these asymptotes, and then I'm going to be looking to make sure that you graphed these points in the right place. And that your line is a nice curve that goes through those 3 points. And that your curve goes along your asymptote on both sides. And that's what I'm looking for. All right, so let's go ahead and answer our questions to this graph. Okay, question on amplitude. Tangent does not have amplitude, okay? There's no bottom and there's no top. It's from -infinity to positive infinity. So we're going to put undefined. Okay, the amplitude for tangent is undefined. The period we have here is how long it takes to repeat our graph. Well, we're going all the way from negative 2 pi to 2 pi. So that's 4 pi. So we're actually going 4 pi for the period. And if you notice, if you remember, we multiplied all of our angles by 4. So if the normal period for tangent is pi, then if we multiply it by 4, then we're going to get 4 pi for a period. Vertical asymptotes. We have two vertical asymptotes. The first vertical asymptote is over here at negative 2 pi, and the other vertical asymptote is over here at positive 2 pi. So what I could write is, on this one, I could cheat a little and write plus or minus 2 pi. And then it repeats every 4 pi. So we could also say that the asymptote is plus or minus 2 pi, and then plus or minus again 4 pi n. Because every 4 pi we get another one. So that's how you would write your vertical asymptotes. The vertical shift was up 1 unit. So we could just say up 1 or plus 1. Okay, so for question 4, we're finding the positive angle in degrees that is coterminal with negative 602 degrees. Well, all you have to do to find a coterminal angle in degrees is keep adding or subtracting 360 degrees, because 360 degrees will take us all the way around the circle back to the next coterminal angle. So we need to also look at our restriction. This restriction says that we need an angle between 0 and 360. So just because I add 360 to negative 602 is not necessarily, it is a coterminal angle, but it doesn't fit this restriction. So I might have to add 360 again. So let's give this a try and see what happens. Alright, so I added 360 degrees to negative 602, and I got a negative 242. Well, that does not meet my restrictions of having an angle between 0 and 360. So I have to add 360 again. And this time when I add 360, I get 118 degrees. So 118 degrees is going to be my final answer. So 118 degrees is coterminal with negative 602 degrees, and it fits within my restriction. Okay, so for the next 3 questions, questions 5 through 10, this is just matching the graph to its parent function, and this is pretty easy. We know that sine and cosine have a wave shape, so we know that either graphs A or graph C is going to be sine x. So we also know that the value for sine at 0 is 0. So we want to look for the graph, the wave graph that has a point at 0, 0. Well, that's this one right here. So we know that the answer to question 5 is graph A. So the question 6 is the tangent graph. Well, we know that the tangent graph and the cotangent graph both are S-shaped, and the value for tangent at 0 is also 0, so we want to look for the graph that's S-shaped that crosses the axis at the origin. So that would be graph D. Then for secant, we know that secant and cosecant both make U-shaped graphs, and that they share points with their reciprocal functions sine and cosine. So if we can find sine, we can find cosecant, and if we can find cosine, we can find secant. So we know that cosine crosses the graph at y equals 1. So that's this one right here. So we know that the answer to 8 is C. And so secant is going to be the graph that also crosses at 1, which is going to be this one. So that's the U-shaped graph that crosses the y-axis at 1. That's going to be secant. F. Cotangent is the reciprocal of tangent. So we know that if tangent crosses at 1, cotangent is going to cross at pi over 2. So that's this one. And it also opens the opposite direction. So we're going to use B for cotangent. And then cosecant is the reciprocal of sine. So we want the graph that has points that touch the sine wave. So the sine wave goes through here. And so the graph for cosecant is E. And that's it. This is going to be the easiest question you ever had on a test. If you missed this, I don't know what to tell you. So good luck on your test. I know the graphing part's probably going to be the most challenging part for you. Just make sure you do all of your homework problems and that you practice. Good luck on your test, Longhorns.